what you're seeing here, there are two coordinate frames. Do you see two coordinate frames? So you have I, J, K. I, J, K, and then you have I, J prime and K prime. Okay, those are two coordinate frames, right? How do you transform from one frame to another? That is not the transformation. That is, you're expressing I prime, J prime and K prime in terms of I, J, K. See, all these, when you talk about coordinate transformations or coordinate frames, each of these axes is a unit vector. It's a vector. Okay. So if you see I prime has a component in I direction. This is just Q11. Okay. It could be somewhere here. It has a component in J direction. It has a component in K direction. Okay. This is the basis for starting your transformation from one reference frame to another. And when you do observations in your geocentric equatorial frame, which is Earth-centered inertial. And you may be required to transfer that, to transform into a perifocal frame or orbit frame. We've looked at that, right? In fact, every observation you make is really in the frame of the instrument. You understand the frame of the instrument? For example, if you're making observations, you have a telescope, right? You have a radar. That is your frame of reference. The frame of reference of that instrument is the frame of reference. Then you're going to transform that to equatorial frame or perifocal frame. Okay? So how do we do these transformations? All right. We won't go into this part. We'll skip this part. We'll start here. This is section 4.5, I think. Yeah, it's 4.5. Okay. All right. We'll start. Take a look at this figure, okay? What do you see here? What you're seeing here is we start with the frame I, J, K. Okay? You see I, J, K? You have I, you have J, and you have K. What you do is you have rotated that frame about the I axis by an angle phi. You see that rotation? You have rotated frame, the initial frame, by an angle phi about I axis. Okay? So what you get here is you have coordinate transformation when you do coordinate transformations, so you have two frames. Frame I, J, K, okay, and frame I prime, J prime, K prime. Do you see the two frames here? It's I, J, K and I prime, J prime, K prime. And the only difference between these two frames is the next frame is rotated by an angle phi about I axis. This frame, so you had this frame to start with, I, J and K, right? And what you did was you just rotated that frame by an angle phi. Now your I prime is just I, right? Because it is in the same direction. Your J, you see J prime. J prime has components in what direction? Can you tell me? Can you look at it and tell me? Say that again. The components are in? Say that again. Right. Do you agree with what he's saying? Do you see why there are components only in J and K and not in I? You see that, right? Because there is nothing here. This is in the plane JK. Correct? So this is your K component. The sine is your K component. And this is your J component, right? Similarly, your K prime has a sine component and a cosine component. Again, this one too, what are the what is this? This K prime has again components in J and K. It doesn't have components in I. You see that? Right? And you should be able to visualize this. Okay? So when you write your J prime in terms of ijk, the way you're going to write is, you're going to write 0 I, because there is no I component, plus, so what is this? This is, you need J component next, right? So this is J cosine theta, right? You see that? And this is in, you can just say cosine theta in J direction, right? plus sine theta in k direction. Okay. The reason, see this, you realize that this, just based on geometry, this is essentially j prime cosine theta, right? If you have, what does your geometry say, or trigonometry say? So you have, this is your j prime j prime. So this is, let's say, pi, right? So this component is what? J prime cosine theta, right? Right? And this component is j prime sine theta. So this, you take the magnitude of this. That is very basic trigonometry, right? You agree with that? What is the magnitude of j prime? What is the magnitude of j prime? If you look at j, you see the hat symbol over there. What does that mean? Huh? The hat symbol doesn't say it's a vector. The hat symbol says it's a unit vector, right? The vector is because it's, here it is bold-faced. So if we were using j prime, we would use something like underscore, underline. Okay? So if you take the unit, you take the magnitude of any one of these, I prime or j prime, it's going to be equal to 1, right? So that is the reason how you get I, j, k. Got it? So similarly, you have k prime is equal to 0I minus sine theta j plus cosine theta k. Now tell me why this is minus. It's in the other, see, if you look at j direction, if you look at j prime, both the j component and the k component are in the same direction as I and j, right? So this is positive. This is positive. Sorry, this is positive, this is positive. But if you look at k, this component has to be negative, right? Because your j direction is in this direction. So this is negative, but this is positive still, because it's still in the k direction. That is the reason you get minus sine theta plus cosine theta. Okay? Now, if I write this, I can, if I capture this in the form of a matrix I, j, k, I prime, j prime, k prime, you have 1, 0, 0, 0, cosine theta, sine theta, 0 minus sine theta, sorry, sine pi, right, sine phi, it's not theta, because we have rotated by an angle phi. So what you see here is, see this one represents a coordinate transformation. Okay? You understand? Make sense? And when you write this, you write it as okay. You capture it like this. You with me? What it means is the transformation when you rotate a matrix about axis 1 by an angle phi, this is the transformation matrix. Okay? And similarly, if you have rotation by 2, the second angle generally that is used is theta. I think it is theta. So what is this rotation? About J by an angle? By an angle phi. Okay. So if you do R2 phi, you're going to get something like this. 0, 1, 0, 0, 0, cosine phi minus sine phi, sine phi, cosine phi. Okay. And R3 phi would be equal to 0, 0, 1, 0, 0, cosine phi, sine phi minus sine phi. You get it? This is clear? There is a very definite pattern to this. Okay. So if you rotate about the first axis, the first component, first row, first column is 1. The rest of the elements of that row and that column are 0. Then you do a cosine, sine, sine, cosine. Okay? And your sign is negative. Sign in the left hand corner is negative. For 1 and 3, the sign in the left hand corner is negative. You see this is negative, this is negative. Okay? If you're doing 3, you're going to first write 3 and 3, third row, third column, it's 1. The rest of the elements of the third column or the third row are zeros. And you again do cosine, sine, sine, cosine. And the left bottom corner is negative. For R2, it changes. Okay? So this again still remains the same. You identify the second row and second column. This is the second row, second column, right? So you have 1. The rest of the elements of the second row, second column and the second row are 0. You do again cosine, sine, sine, cosine. Here, this is negative. The right hand side, right top corner is negative. Okay. Now, the reason we introduce this is any coordinate transformation. Okay, so we'll take a look at a very complex coordinate transformation. So this is, you identify this. This is a rotation about k direction, right, or z direction, or third axis. You can recognize this 1, 2, 3, right? 1 means I or x, 2 means y or j, 3 means k or z. Okay, so this is a rotation about k, z axis. Now take a look at this. This is a complex rotation. You see? Focus on this for a while. You have the initial coordinate frame here is x, y, and z. Okay? The final coordinate system or coordinate frame is x prime, y prime, z prime. Do you see it? You're going from x, y, and z to x prime, y prime, and z prime.
So for alpha angle, they rotated about z. For beta angle, they rotated around the x.
We'll get to that. We'll do that. So the way you're going to get that is, you can get to any rotation from one rotation to another by using a combination of these three. Okay, so this, when you do a 3D rotation about an axis, see this rotation, if you look at the rotation x, if you look at the two reference frames, x, y, z, and x prime, y prime, z prime, it is not about any of these primary axes. Okay, it's about a random axis. So how do you go to that random axis? You use this combination. Okay, so if, for example, the first rotation you're going to do is this 1. You see 1? So can you identify the 1 rotation? What is this rotation about? What is it about? It's about z axis, is it? Right. So you see, it's about, so this is changing. It's about z axis, right? So if you have this, you do this, your x and y will change, right? You see x and y changing. The new x is x1. The new y is y1. Right? It is about the z-axis. So z1, see, the way of looking at it is z and z1 are the same, right? So if z and z1 are the same, it is about z-axis. Because it is that axis remains, it doesn't move, right? So that is the first rotation. So what you do is, you want to relate the initial and final, right? So which rotation is that? Which rotation matrix are you going to use? This one, or this one? R3, right. So you're going to use R3 for the first rotation. Okay. The second rotation, can you identify the second rotation? So now your new axes have changed. Okay. Sorry, axes have changed. So the coordinate frame is Z1, X1, Y1, Z1. X1, Y1, Z1. The second one is about? Right. Because your X1 and X2 are the same, right? So it is about X. So you move it. By angle? By angle beta. Okay, so which rotation are you going to use now? You have to use R1 because it's about X. You use this. You only change the angle. Here it was about pi or by an angle phi. Here it is angle beta. Okay, so you change this. What is the final rotation? Final rotation is about? Take a look at what final rotation is about. You sure? It is about Z. It's not about Y. So you see Z, Z2 and Z prime. Z prime is like Z3. So Z2 and Z prime are the same. So it's again about Z. And it is by angle gamma. So what you're doing here is foregoing the let us try to use something consistent. Okay. These are elementary rotations, okay? All these three. These are very basic elementary rotations. And if you want to go from, so let's look at this Q. This Q represents the called direction cosine matrix, okay? And what it represents is Q represents coordinate transformation. So when we are talking about coordinate transformation, what we are going from frame X, Y, Z to frame X prime, Y prime, Z prime. Okay, and Q direction cosine matrix is essentially R3 by beta, gamma R1 by beta, R3 by alpha. Okay. If you do these matrix multiplication, you're going to get the coordinate transformation. Okay. So this Q will essentially take you from X, Y, Z to X prime, Y prime, Z prime. Now notice something very important here. Okay? Pay attention. We actually started from alpha, right? Our first rotation was alpha. Correct? Our second rotation was beta. And our third rotation was gamma. This sequence matters. Okay, so you pre-multiply the sequence, the rotation matrix. You don't post-multiply, you pre-multiply. Your first rotation matrix was this. You take just this, you pre-multiply that by beta. Now we are going to use double underline because this represents a matrix. Now what single underline represented are vector. Okay. Yes, Dion. Right. It is still z-axis, right? 3 means z-axis. There is no 2-axis here, actually. We are not rotating about 2-axis, right? No, we did not rotate about y-axis. We could rotate about y-axis, but this is one of the classical sequences. It's called Euler Sequence. Okay, it's a 3-1-3 sequence. And what it does is, if you take, we have learned what are the orientation angles for orbital elements. You remember the orientation angles? Orbital elements, when you talk about orbital elements, you talk about I, these, right? These angles. You remember these angles? Now, if you are in the ECI frame, okay, X, Y, Z, and you rotate that frame by these angles, you first rotate by cap omega, then you rotate by small omega, and then you rotate by I, you'll end up in perifocal frame. You'll go from Earth frame to an orbital frame if you do a 3-1-3 rotation. So this is 3-1-3 rotation. Yes, we'll actually this is it is. Yeah, this is a sequence, okay? And when you're multiplying, you take the opposite. Okay? So your Q is equal to R3 small omega, R1 I, and R3 cap omega. This represents rotation from Earth frame to orbital frame, and this is it was a very natural thing which came about. Okay, it is very convenient to do this rotation and see. For example, if you're standing on Earth, right, and you actually go through this rotation yourself, you'll be in the orbit frame. You won't go into an orbit, but you'll be in the orbit frame. It's a very convenient way of visualizing. Get it? A lot of your video games, a lot of your, for example, your cell phone gimmicks have been possible because of all this. Okay? Is this clear? Math is actually very simple. You only have to remember these three and the sequence, and you can go from any rotation to any reference frame to another reference frame. That's the math. If you look at, I can justify the math, but it will be out of the scope of this class. I can justify to you why it is pre-multiplied. See, when a lot of these maths, the people who developed them could see them right away, that yes, it needed to be pre-multiplied. And it is justified as to why you pre-multiply. But for this, the purpose of this class, it is not required, or it is out of the scope of. And if you really want justification, you can come to me and you can seek the justification. I'll tell you why it is so. Okay. This is chapter. Sami, just give me your attendance, please. This is chapter, I think chapter 4. Yeah. Any questions until now? I will send out an exam, a sample exam, which will also be your homework today. Try to do it during the weekend. We can discuss something on Monday and Tuesday. All right? And the extra credit, some of you have submitted. I would strongly recommend that many others try to do it. Okay. And if you need help, you can come and ask help for it. MATLAB, you can always come in, because it is not in the frame of the syllabus, so